Welcome back to this session of our lesson. We are still looking at trigonometry. We are going to, in particular, look at the sine ratio. Okay. Now, in our last lesson, we saw that the sine ratio, sine ratio is the relationship between the opposite and the hypotenuse. Okay, that much we determined in our last segment of the lesson. Okay, sine theta equal to opposite over hypotenuse. Now, remember that the sides are named in relation to where the angle is. Okay, so theta opposite is here, and we have adjacent. Okay, so we are going to see how we will use this ratio to find the length of sides in a triangle. Okay, now example number 1, we are asked to find x. All right, so we have a right angle triangle. Okay, hypotenuse measures 40 meters. Okay, this angle here is 35 degrees and x is this distance here. Okay, now notice x is directly opposite to 35 degrees. That is why we are using the sine ratio to find the value of x. Okay, so let's see. Sine theta, let's rewrite that first, opposite over hypotenuse. Let's look at our diagram. Theta is given here as 35, so we will write sine 35 degrees equal to, the opposite side is unknown, so we write x over the hypotenuse of 40 meters. Okay, now we are going to approach this like we are solving an equation, so we need to take 40 across to this side by multiplication. All right, so 40 sine 35 degrees is equal to x over 40 multiplied by 40. Okay, so this is going to cancel out, and you are left with x equal to 40 sine 35 degrees. Okay, now once you've reached this point in your working out, you have to go to your tables, your trig tables in your textbook, and find the value of sine 35 degrees. Now make sure you are looking in the right column in the tables. Okay, find angle 35, go to sine and find its sine value. Okay, so according to the table I have, sine 35 degrees is 0.5736. So 40 is going to be multiplied by 0.5736. Okay, now remember, anything in brackets indicates multiplication, so 40 will be multiplied by 0.5736 equal to x. All right, now be careful with the multiplication here, because you are now multiplying a whole number by a decimal number. So let's come to this corner here where we have a bit of space and do that multiplication. So we have 0.5736 multiplied by 40. All right. Put down 0. 4 6s are 24. All right. 4 3s are 12 plus 2 is 14. 4 7s 21 plus 1 is 22. And 4 5s are 20 plus 2 is 22. Okay. Now, because our question here has 4 decimal places, we will move our decimal point 4 places. Okay, so the height of our triangle here, or the value of x, is 22.244. And don't forget, the unit of measurement here is 40. So our answer is 22.244 meters equal to x. All right. Now remember, the unknown side is opposite the given angle, and that's why we are using the sign ratio. Okay. Now how do we apply this to everyday situations? Now imagine if, let's look at example number 2. Imagine if we have a wall. Okay. Now don't mind my wall, please. It looks all right. Okay, and we have a ladder that is 10 meters in length, leaning against this wall. Okay. It forms a 40-degree angle right here. Okay, 40-degree angle. I want to know how high this wall is. Okay, I want to know how high this wall is. So I'm going to find this side here. It is currently unknown. Okay, it's unknown. Now how do I find the length of that wall there? Again, notice that that unknown side is opposite the given angle. So you are using the sign ratio. Okay, so let's rewrite that formula. Sine, remember you are using the angle, so 40 degrees is equal to, the opposite side is x. All right, and remember I mentioned your ladder is 10 meters long. So that's going to be over 10. All right. So once you have all your values into the formula, you are simply going to work it out. Again, bring 10 across to this side here. So let's see. 10 sine 40 degrees is equal to x over 10 times 10. Right? It cancels out on this side. Okay, you're left with x equal to 10. Now sine 40, you will again go to your tables, find 40 degrees under the sine column, and write the value here. Okay, so sine 40 is 0.6428. All right. Now notice that you are multiplying by 10. So we don't need to do what we did here. I can simply move my decimal point once in that direction. So x is equal to 6.428 meters. Okay, so the height of the wall here in this diagram is 6.428 meters high. All right, now I hope you've learned something here, and where we apply the sign ratio. Only when the unknown side is the opposite side, then we apply the sign ratio. Okay? Now, few reminders. Be careful with the tables. When you are going through the tables and you need to find the sign value, make sure you are looking in the right column. Okay? It's a common mistake to get your eyes confused because of all those numbers that are in the table, and you look at the wrong column, okay? So be careful, take your time. In the next lesson, we are going to look at the next ratio, which is the cosine ratio, all right? Now review what the cosine ratio, the sides which we are using in the cosine ratio, okay? It's in today's lesson. So next lesson, how do we use the cosine ratio?